Hi. First and foremost, I would like to congratulate ICANN 2024 for the organization for successful or penetrating all the difficulties and successful organization of ICANN 2024 for their ninth edition. Today I'm going to share with you my research, one of the research and the outcome of the research. My research title is Efficiency and Effectiveness of Ultrasonic Membrane Anaerobic System humus in the operating or the organic pollutant removal. My name is Professor Abdurrahman Hamid Noor. Background. So one of the waste treatment issue in the world, this is the Malaysia is among the most largest producers of palm oil effluent. They produce 35% of the world vegetable oil and 48% of the palm oil produced in the. So the palm oil produce 21 million tons a year. That's 21 millions a year. They required 42 million tons of the water, wastewater. So that means if Malaysia produced 21 million, 1 ton is requires 2 tons of wastewater. So 21 million. So Malaysia produced 42 million of waste. In order to treat this, you need very efficient way in order to treat this. Also, Indonesia is the neighboring country for Malaysia, and also Indonesia is the largest producer of the world, and Indonesia produce 42 million ton a year for the waste treatment. To produce this one, the 85%, more than 85% of the palm oil milliones, slaughterhouse water, sewage, sludge, all these in Malaysia, they use aerobic system. The aerobic system because they use the sunflower direct, the sun direct, and the advantage of this one aerobic system is ponding system, aerobic system because of the low cost capital, low operating costs and low energy requirements. But the disadvantage of this, they use very long retention time, hydraulic retention time. They use it also large treatments, and the most difficult for the when you use aerobic system, the retain of the methane gas. That is one of the, so we treat that one. So in order to come with the problems, we use ultrasonic membrane anaerobic system. I use for the last 3 years in my research membrane anaerobic system in order to retain the methane, because all the industrials, they move from aerobic to anaerobic because the disadvantage of aerobic, they cannot catch or the constrain or they catch the methane gas CH, because methane gas is one of the valuable values of the so they move from aerobic to anaerobic. In anaerobic, yes, you can use the membrane in order to catch or in order to retain the methane gas. However, the main problem of anaerobic, the fouling problem, because when that is occur, you have to stop all the system, then you pull out the membrane from membrane housing system, and we use the chemicals in order to clean the membrane or flush with water, then retain that. That if you are doing in the small scale or in the lab scale, that's fine. But however, if you are using in the industrial scale, so if you stop your system for 24 hours, then that's you lose a lot of money. So from that point, I come with the design, new design, in order to solve the anaerobic problem for that one and fouling problem. I designed it an anaerobic system with the ultrasonic. I introduced, it is first time introduced ultrasonic with the 4 transducers along the membrane. Later I will show you the details of the design, the use. So this is the reduce the advantage, reduce aerobic treatment from the time, then to reduce the plant flow area because the system from the horizontal to vertical, and reduce the biomass of the system. This is my design. I use the reactor, membrane anaerobic system, or the system of that one, and this is the whole design of my reactor. So it has, if you see the reactor, then you have the pump, then you have the reactor, and the waste, you put in the waste inside the reactor. Then we have the pump. The pump is taken from the reactor to the membrane anaerobic system, then circulate it, The treated one, they come out with the permit, and untreated is goes to circulate. While we're doing that, on the top of this the reactor, we have the gas collector. So we gas collector is connected to the GCMS gas, the gas collector with the GCMS in order to capture the gas. Then the system also, one of these, this is a complete our system. As I mentioned earlier, this is our system, and we also, one of the outcome of the products, we publish 2 books. We publish 2 books of the one was the water quality and biological wastewater. So this is a very significant, and also we publish in very high impact factor journals in desalination of our product. And also we have 2 patents. We have a 2 patent of then we secure 500,000 ringgit for the research for this very significant. We published the produce, and also we bought our patent. The patent is a granted patent. Then the patent is a PI 2027. Then the patent is a granted, and which is the granted. Then we come with the industrial, so they come with the evaluation of and we got 750 with the value of the patent. We sold it. This is a patent. Then we have, these are the results of our whole the product. We use the carbon dioxide, gas production. These are elements with total gas yield, methane percentage, CH4, mixed liquid suspended solid, volatile mixed suspended solid, volatile, hydraulic tension time, organic loading rate, substrate, suspended substrate utilization rate, and we use comparison between membrane anaerobic system and ultrasonic membrane anaerobic system, and these are results, and the results are very clear. So the ultrasonic membrane is much better in terms of the performance, because we introduce ultrasonic to reduce the fouling problem. So these are some of our results, and what I'm trying to say that our system is reduce the time from 60 days to only 28 days to produce the methane gas. Also, we reduce the plant area from 80% to 80%. Then the experimental data filled with can be the data for the mathematical models for any future research for the development. So the advantage of our system improved the CH3 production by 19% from the total. So we produce 79% of the methane. Then we reduce the carbon dioxide COD further to 96%. The performance, the removal of COD to 96%. Then we reduce the retention time, and this is a very significant. We reduce from the aerobic is 60 days, from 60 days to only 28 days, and we produce fully methane gas. And also the plant size, because the conventional they use horizontal, we use a vertical, from the reduce from 1,000 to only 50 meters square to produce the same amount of the production. The novelty of this, we able to to design the system, and successfully we apply the system and produce the methane gas. The system is already commercialized. Also, our product is commercialized by the international company, economically friendly, avoid the fouling problem of the membrane, also reduce the retention time from 60 to 28, and the system is vertically, and we reduce very little areas. Then the project has secured patent values with 900,000 from the industrial, and this 2,000 for 24, and also we secured international grant 500,000 for the research, and that is one of the significant of this product. The commercialization, in terms of the commercialization, as I mentioned, we already commercialized this system with the patent is 900,000 ringgit Malaysia, and the materials construction is no restriction. The most important, the construction of the system is there is no restriction of any construction of material, Then the operating the pH is from 6.8 to 7.8. Then 5-ton membrane anaerobic system is a module can cost less than 50,000 pounds, and that is one of the very significant on this. Then we can say it we from the waste to wealth, and the system is successfully we produce and commercialize. Thank you.